Welcome to Genius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hello students, I'm so glad that you're here. In this video, we will learn the basics of pH and how we can use a simulation to show the variation of pH with different solutions. We will also talk about the relationship between the pH concept and other subjects like biology. This topic is discussed in Senior 1 and Senior 6 according to Rwanda Education Board curriculum, but here we shall limit our tutorial at Senior 1 level, as 6 will be discussed in another video. For S1, this lesson is covered in Unit 11, Acids and Bases, and pH. And the simulation we will explain today is the pH scale basics. First of all, let's look at the objectives of this lesson. At the end of this video tutorial, you should be able to define pH, explain how the pH scale helps to classify solutions, and use the simulation to prepare solutions of various pH values. Here we have some important definitions to know before we can go to the simulation and know how it works. What is an acid? You remember the definition of an acid? An acid is a substance which produces H-positive ions in a solution. It has a sour taste, an acidic solution. It's like lemon, for example. Lemon juice, it is acidic. That taste is for acids. What is a base? A substance which produces OH ions in solution. As we said, this is a video tutorial for Senior 1 level and other students who may want to revise. And the advanced explanations of this topic will be for Senior 6. So these are the simple definitions of acids and bases. A base has a bitter taste and it has a soapy feel. Now, what is a pH? A pH is a measure, quantitative measure we use to determine if a solution is acidic, basic, or neutral. And then from the pH definition and the measures, we can establish what is called a pH scale. On the scale, we have values from 0 up to 14. It is shown here. From 0 up to 6, this is an acidic region. This is our pH scale. So different acids, depending on whether they are strong or weak, depending on how strong or weak a solution is acidic, it will have the values from 0 up to 6.9 something, because 7 is neutral. And from 7.1 up to 14, we have basic solutions, the basic solutions. There is something here which is very important. Here we use an indicator when we use what we call the universal indicator. We get different colors depending on the pH value of our solution. If a solution has a pH of 9, then its color will be light blue like this one. If it has a pH of 3, the color will be yellow like that one. So the color can help you to know whether the solution is acidic or if the solution is basic. It can also let you know if the solution is neutral. So here we have different everyday substances, our everyday life substances, like the acid we use in the batteries, car batteries, the lemon juice. You can see their relative pH values. The wine is also acidic, and normal rain, you can see the normal rain is acidic also, because it is in the pH range of 5, 6. and distilled water is neutral. Baking soda, this is sodium hydrogen carbonate. It is slightly basic, while this one lye, and this is a solution of wood ash, but it mainly contains potassium hydroxide and sodium hydroxide. You can see it is strongly basic, and ammonia, which is weakly basic. And even the soap is basic. Now let's go to the simulation and see how we can use it to show the different pH values of. Now let's go to the simulation and see how we can use it to show how different solutions have different pH values, how different solutions may be acidic, how different solutions may be acidic, basic, or neutral, but still for the neutrality or for a neutral substance, we always consider distilled water. Here you go, we have our simulation. And here, let's start with the explanations of the different parts of the simulation. Here we have a dropper which will drop the solution in this beaker. Let's say that here we have a plastic beaker or a beaker which is graduated, okay? It's a container. And here we have a tap that we can reduce, we can use. Here we have a tap, and here we have a tap that we can use to reduce the volume of the solution. Here we also have a tap we can use to increase the amount of water in the solution. That means we can use it to dilute our solution. And here we have a button we can use to test the pH. You can see the pH scale here from 0 to 14. And here the pH value will be indicated depending on the type of the solution we are using. You are used to this button. When you press on it, you reset everything. Now let's start with this chicken soup. The chicken soup, we add some of it in the container, and then we use this to check the pH. You can see the pH of the chicken soup is 5.80, the value which shows that it is acidic. It is slightly acidic. Below 7, it is always acidic. Now, what do you think will happen if we add some water to this solution? Will the pH increase or will it decrease? Let's find out. The pH value is increasing. What does it mean? When the pH value increases, it is approaching the neutrality. It means that the solution is becoming less acidic. So when the pH value is greater, but less than 7, the solution is less acidic. And what happens if you add more chicken soup? The pH is decreasing. Let's add more. The pH is decreasing. Showing what? Showing that the solution is becoming more acidic again. And what do you think will happen if we reduce the volume of this solution? Let's find out. And see, there is no change because we are not increasing the concentration of our solute. The solution is not changing in nature. The only thing we are doing is changing its volume. Okay? And as I said, if you add water, the pH increases to show that the solution is becoming less acidic. Let us use another solution. Before that, let's reset and we take another solution. Let's use something like vomit. Vomit. What happens? We add some vomit in the container, and then we check its pH. It has a pH which shows that the solution is strongly acidic. This is a strong acid. Why is it a strong acid, or why is the solution strongly acidic? Remember, vomits come from the stomach, and in the stomach we have an acid. You remember the name of that acid is hydrochloric acid, and that is a very strong acid. So that is the reason why the vomit is strongly acidic. That is the reason why, if you allow me to go in another subject which is related to this concept of pH, that is biology, that is the reason why when you have an indigestion, you get a heartburn. Why? Because the excess acid moves up. As it moves up, you can feel the acidic solution, which is burning you. And that is the cause of what we call the heartburn. Now, let's continue. What happens when we add some water? Will it be like what we have observed with the chicken soup? You add water, the pH value increases to show that the solution is becoming less acidic. So every time you dilute a solution, it becomes less acidic and its pH value increases. In the solutions we have here, we don't have acidic solutions only. We also have basic solutions. Let's use this one, the hand soap. Hand soap, see, we have a pH of 10. This is really basic. So soaps are basic. And what happens when we add water? The pH decreases. So in this case, because it is a base, adding water or diluting the solution will reduce the pH value to show that the pH moves towards the neutrality. Okay, so every time you add water or you dilute a solution, the pH value will move towards the neutrality. That is the general observation. That is what happens generally. But for acids, it will increase, the value of the pH increases, and for bases, it decreases. Why? Why? Because for the bases, it decreases when it moves towards the neutrality, and for the acids, it increases when we move towards the neutrality. What happens when we use a body fluid like blood? What is the pH of blood? Let's find out. This is enough. We check. It's 7.4, slightly basic and almost neutral. And here let's again come back to biology. This concept of pH is very important in biology because some body fluids or some metabolisms in our body, they take place at a given, this is because some metabolic processes, they take place in very defined pH ranges. And if you change the pH, the process will not take place normally. It may even fail to take place. So we have to make sure that we maintain that pH range. For our maximum functioning and good functioning of cells, for example, there should be a given pH value or pH range in the body, in the blood. And if you change that, you will change everything, and even the people can die. We also use this pH concept in food production, for example, and food preservation. For example, when you make, or when, for example, when you add in food something like vinegar, which makes it slightly acidic, you can preserve the food for some time because there are some microorganisms, those which are responsible for spoiling the food, which will not live in an acidic medium. So the pH concept is not only found in chemistry, but it is also necessary in biological processes. So what happens when we add some water to this blood? The pH decreases because we are diluting. The pH moves towards the neutrality. Okay? Do you know the pH of orange juice? The orange juice, I hope you like orange juice. Let's find out. We have the orange juice here. You can see it's very acidic. This is acidic. So if you have a problem in your stomach, if you have stomach ulcers, for example, it is not good to take orange juice. But if you like it, what you can do is to add some water and reduce the acidity, okay? You can dilute it and reduce the acidity. Here we have milk. What is the pH of milk? Is it basic? Is it acidic? We add some milk. Wow, it is slightly acidic, but this is almost neutral, slightly acidic. If you add water, it's the same thing, becomes neutral. You add some water, it moves towards the neutrality, okay? And what about the spit, the saliva? Just like blood, body fluids, okay? The body fluids. When you add some water, the pH value decreases. And as we said, you can reset. So this is how we can use this simulation to show what happens with different solutions when you are analyzing their pH values. We have also seen what happens when we add some water. When you dilute, you make the solution less basic or less acidic, and the pH values in that case will move towards the neutrality. For the acid, the pH value will increase, while for the base, the pH value will decrease. I hope you have enjoyed the video. Now, let's go to the quiz. Let me explain how you can take the quiz. If you feel confident, you are ready to take the quiz, this is how you will take the quiz. The quiz code is VID 001006. And for those who don't know yet how to take the quiz, here we have the steps. You go to the website www.opanda.xyz. You click on login. It is here marked with a tick. And then you click on take a quiz. After taking the quiz, and then you click on take the quiz. After clicking on take the quiz, you will get this interface, and here you will type the code, that quiz code, and then you take the quiz. Thank you very much for watching. I hope you enjoyed the tutorial. See you next time for another video.